Assalamu alaikum everyone. So in today's class we will start a new chapter from class 12, second chapter of class 12, the inverse trigonometric function. Inverse trigonometric functions. So from the name of the chapter itself, we can understand here we are finding the inverse function of the trigonometric function. Suppose we are having a function f, the inverse of that function is f inverse. Okay. So we will discuss some basic concept of function and inverse function. Okay. So if you want to find any inverse of any function, that function must be 1, 1 and 1, 2. Okay. So consider a function f from a into b. A function f is defined from a to b. Okay. Here in this case, here we are having a function a connect to 1, a set from a connects to one element 1 from set B. Here also B, 2 and C, 3. In this case, every element of A connects to some elements of B, or we can say every element of A has some image, in set B. So it will form a function. Okay. It will form a function. This relation will form a function. Another, in this case, here the two elements from the set A connect to same element from set B. So, okay, and C belongs to connect to 2. In this case also, we can say it will form a function. Okay, that means every element of set A must have an image in set B, then it will form a function, or we can say it will have some element. If some elements have same image in the set B, then also it will form a function. Now consider the third case, name 1, 2, and now consider the third case. See here, in this case, the element A from set A connected to two elements of set B, or we can say this element A has two images in this set B, then the condition for the rule for the function is every element must have only one image in the set B. Here we are having the set this element A has two images in set B, so it will not form a function. Okay, it will not form a function. See, in the third case, we can see here is this A connect to 1 and B connect to 2. For C we are not having any element which will form the image of C. Okay. So in this case also it will not form a function. So understood what is function? If every element of the set A connect or have an image in the set B, or in some cases the same element with the different element in the set A will have a same image in the set B. In this case, different element will have same image. Okay. In this case also, it will form a function. Okay. So now, what is 1, 1 and 1, 2? You know that you have studied in this chapter 1. We will discuss about some basic concepts so that it will be easy for you to understand the remaining concept. Okay. Now consider the case, the 1, 1 and 1, 2. What is 1, 1 and 1, 2 function? Okay. Now consider seeing set A and a function f from set A into set B. A function A from set A into set B. Here we are having two sets A and B. Set A, set B. So now we can connect this. Here you can see every element of the set A has only one image in set B. So it will form it is known as a 1, 1 function. What is 1, 1 function? Every element of the set A must have only one image in the set B, that it will form a function, 1, 1 function. Okay. Now consider another case where we are having, suppose set A and B same. A, B, C. The set, name this one B. Okay. Here, the two elements A, B from set A connect to one element, one in the set B. Or we can say A, B having same image. So it will not, we can't say this one is a one-on-one function, it is a many-one function. Many-one function means every element of the set A will have one and only one image in the set B. Then only we can say this one is a one-one function. Otherwise, it will a many-one function where different element have same image in the set B. Okay. Now, what is onto function? Well, we are discussing because we should have to know what is one and onto. Then it will be useful for further finding the inverse of a trigonometric ratio or the finding of a function, inverse of a function. Now consider a case. Consider a function which is defined as from A into B, then A, B, 1, 2, 3, A, B, C. See here, 1 and 2 belongs to connected to only one element A and 3 is connected to B. And what about this function C? C is not having any element which will connect to this element from set B. Then it will not form a function, or we can say it will not form a onto function. What is onto function? Every element in the set in the set B will connect to some element in the set A. Every element will form an image of some element in set A. So A is the image of 1 and 2, B is the image of 3. We are not having any element which will for which C is the image. So it will not form a 1-1 function. So what is 1-1 function? See here. Consider a set A and B. Here 1, 2, 3, 4. Here A, B, C. Okay, suppose. Now 1 and 2 connect to same element A in the set B and 3 connect to B. Means A is the image of two elements 1 and 2 from set A and B is the image of 3. And C here, C connect to 4, that means C is the image of element 4 in the set B. So here it will form a onto function. So what is 1-1 and onto function? 1-1 means every element in the set A, B in the second set will every element have only one image in the set another set. Then we can say it is a 1-1 function. Again I will write for 1-1. This one is 1-1 onto function. Here we are having A, B. It is A, B, C. 1, 2, 3. A connect to 1, B connect to and C. So it is a onto function where, 1-1 function. 1-1 function. Okay. Here every element of the set A or the first set or domain, every element from the domain will have only one and only one image in the set B or codomain. Then we can say it is a 1-1 function. Otherwise it will form a many function. In many one means we are having a different element having same image. In this case we can say it is a many one. In 1-1 every element will connect to only one element, or every element will have only one image in the set B. Then we can say it is 1-1 function. Here what is onto? In the case of onto, you have to check for the second set, okay, in codomain. here in this case for onto, every element will be the image of the some element in the set A, or you can say every element in the second set of codomain will be the image of the element from some element from the set of A or domain. Every element here, it will, in here you can say C will not connect to any element in the set A. It will not form a function, it will not form a onto function. Okay. So clear? 1 1 and onto 1 1. Every element of this domain set will have only one and only one image in the set B. It is called 1 1 function. What is onto function? Every element of the second set or the codomain will be the image of some element in the set A. Every element must be the image. Okay, then we can say it is onto. In 1 1, every element have only one and only one image. So it is clear. So for finding the inverse of a function, the function must be 1 1 and 1 2. Why? Why? We will discuss. Okay, we will check why it is necessary for a function to form a, for finding inverse of a function, why it is necessary the function should be 1 1 and onto. Okay, we have to check. If a function is on 1 and on 2, we can say that function is a bijective. You have studied this in the first chapter. Now, consider a function f which is defined from A to B. Here, A and B. Consider two functions. 1, 2, 3. A, B and C. 1 and 2 is connected to the set A, element A, okay, and C is connected to B, B is connected to this. So here we can say the two elements have only one image, so it will form a many-one function. It will not form a one-one function, but it is a onto function. Why? Because every element A and B connect to the some element of B, or we can say every element in the set B, every element in the set B is the image of some element in set A. So it is a one onto function, but it is not a one function. Now we will find the inverse of this function. Suppose f, if we are finding the inverse of this function, then it will become inverse is f from B into A. Okay, now write down B A. Okay, here in B we are having, if you are taking inverse, the domain become codomain and codomain become domain. Means A become the set first set here will we have to take B. Now here 1, 2, 3. Now 1, 2 connect to A in F. 1 and 2 connect to A and 3 is connect to B. But we know that every element will have only one image in the set codomain. In this case, we are having the element A has two images in the set, in second set. So it will not form a function. If it will not form a function, then how can we find the inverse of this function? Okay. So it will not form a function. That means we can't find the inverse of this function. But it is a bijective. How? Every element is connected to some element in the set B. Every element is the image of the element in B. So we can say it is a bijective function. Now consider a function f from A to B, f from A into B. Consider two set A, B. Okay, here 1, 2, 3, A, B, C. 2 is connected to A and 1 is connected to B. C is connected to C. It is a function. Now we have to check whether it is 1, 1 and onto, if it satisfies the condition for 1, 1 and onto or not. Okay. Here every element has only one image in the set B, so that means it is a 1 1 function. For bijective, what is condition for onto? For onto, every element in the second set B is the image of the first set. So it is a by 1 1. Now 1 1 also and onto. That means we can say this one as a bijective. So now if we want to find the inverse of this function, see what happens. Inverse is B from f inverse is f inverse from, it is defined f inverse from B into A. Okay. So now write down element of the set P. Here we are having A, B, C, and here it is the element A. So 1, 2, 3. 1 is connected to B and A is connected to C is connected to 3. Okay. Here A is connect every element in the set A in the first set connect has only one image in the second set, or every element in the domain has only one image in the codomain. So we can say this one is a one-man function. Okay. And for on two we have to check every element is the image of some element in the first set or the domain set. So we can say this one is a one-one and onto function or the bijective function, so that we can find the inverse of a function. So remember, there is always, it is a rule, it is very important rule. For finding the inverse of a function, the function must be one-one and onto. What is one-one? The every element in the first set will have only one image in the second set. Okay. And what is onto? The every element will form an image in the first set. Every element will be the image of the some element in the set P. In this case, in the if it will not, we have so in this firstly we have discussed about what is function. If every element has image in the second set or the codomain set, then it will form a function. If it may be have the some elements connect to same elements, then it will also have form a function. If the same image having two images, if the same image, different images having same, then it will be form a function. If same no one and no one function, sorry, so here one element having two images, then it will not form a function. Okay. And consider another case where I am writing here set A and set B. 1, 2, 3, A, B, C. It will connect like this and it is connect. What about C? Here the set C will not connect to any element in the set A. Then it will not form a function. So that means every element will be the image of the second image of the some element in the set A. So to form a function, it will be form a function if, see here, 1, 2, 3, 4, A, B, C. Okay. A and B connect, 1, 2 connect to A, B connect to C, and sorry, B, 3 connect to B, 4 connect to C. So C is also connected to one element in the set A, then it will form a function. In this case, it will not form a function. It will not, we can't say this one is bijective. So it is very simple to find the inverse of a function. That function, given function must be one-one and onto. So why we have see here, if it will not have, if the given function is not one-one and onto, then it will not form a function in the inverse form. That's why it is necessary that the given function must be one-one and onto. And we have checked, if the given function is one-one and onto, then in the inverse form also it will we also it will form a one-one and onto function. Okay. So I will continue in the next class. Thank you. Today I have taken only some basic concepts. Thank you.